This video is concerned with discriminated unions in F#, and these are quite useful when you want to group various types of objects together into one structure. Let's say you want to create the input attribute of some function, and you want to be able to send a number of related types, let's say, to that function. Now, it's quite flexible in how you implement it, which makes it quite appropriate if the inputs can vary quite a lot between each other. So it allows you, for example, to define a shape, which is what we're going to do in a second, and then define a number of different shapes as, well, if you're familiar with inheritance, I would say like as extensions to that. That's a way of thinking about it. And it allows you to be, as I said, quite flexible with how you define these. So let's actually start typing this out. So let's make a discriminated union type called shape, like this, and we would separate the different constituents here, or the possible instantiations, with these pipes. So first of all, we can define a rectangle, like so. There we go. And the way you would specify this, so we call it rectangle, and that's what you would initiate it with. But then normally this would have some set of parameters as well. And the way you write this syntactically is of, you're using the of keyword, and then you would have something like width for a rectangle, and in this case that would be a float. We would do that so, and then you separate the different parameters with these multiplication signs, so, or the asterisks. Then we might have length would be the second parameter here, and we would also let that be a float. So this would be one possible shape. Now once we've done this, we can define a new one, and this could be a circle, for example. So let's write circle here. Again, we would use the of keyword here, and we would specify the radius, and that would be a float. And you can see here that the circle only takes one parameter when we initialize it, and the rectangle takes two. And there's no problem in having different instantiations or different numbers of parameters for the different types here. We could define, well, even more types if we wanted to, but we don't necessarily need to do that. So once we've defined a discriminated union like this, we can instantiate the different subcomponents here with just the let command. So we could do a rectangle, like call it rect, then we would simply write rectangle, and you even get that as syntactical highlighting, so you can simply select it, and then you would specify the parameters, and you do this in parentheses. So we would say that the length is equal to, we can do like 1.3, and then we would specify the width parameter, and in this case that would be maybe 10. Okay, like so. Fine, so there we have a rectangle, and we can do the same thing for the circle. So we define circ here, and we would initialize it in the same way, and we get the highlighting here for circle, and you see that it even highlights radius for us there. So we don't even need to specify that it is the radius. We can just give it 2.0 as the input parameter here. Cool, so now we have a rectangle and we have a circle, and these are both part of the shape attribute. So you could, for example, have a function that accepts a shape, and then you could send it either a rectangle or a circle like this. And one final remark that I would like to highlight is that the option type, which we've specified before or talked about in previous videos, is in fact an implementation of a discriminated union. So the way that is actually defined is you would write type option. So remember, the option is what we, well, this is how we specify an option, and we would give it a generic parameter. This is how we specify that. So this quotation symbol and then an A, and in here there would simply be a type called sum. And you remember that when we talked about these option types, sum is how you define or specify when you actually have a value, and then we would say of, and this would be the generic parameter, like so. And the other alternative would be none. And you can see that this is like exactly the kind of structure that we used before. Sorry, I got auto completion for the array here. That would simply be -8.